All right. I am not sure what I'm doing. Okay. Good afternoon, good morning, good evening. I actually kind of want to share this with a couple of friends. Hold on, give me a second. Just give me 1 second that I wanna really check something. I wanna check something. Wait. Hold on, hold on. There you go. All right. Yes, so where are we? Okay. Hello. Whoop, whoop, whoop. Hello. Good afternoon, good evening, good morning, whatever this is to you. So, for those of you who may not know me, my name is Jose Luis. I run this thing, but you know all this stuff already. Okay, so let's cut to the chase. So we've been working on this computational Christmas tree that has these lights that can be controlled with sequences and with individual RGBs. All right, and we've done a bunch of videos where we have learned how to generate these sequences. Computationally with Grasshopper, writing code, etc., etc. And we have tested them in simulation. So that was okay, that was fine, but I mean, the real thing is the real thing, right? So this live stream is basically going to be recording a video where we run all those sequences that we have done in the previous videos. We run it on a Christmas tree with illumination that I have on my living room right now. Okay, so how is this going to work? So I have a webcam in my living room connected to this whole system, and so what we're going to do is that I'm going to go to the living room and I'm going to introduce the video from the living room, and then I'm going to come back here and I'm going to load all the sequences and all this stuff from the comfort of my recording studio. Okay, so how does that feel? All right, this is going to be probably quite bumpy, so bear with me. So I'm actually kind of excited. It's like I'm testing a new format of sorts. All right, so I'm going to switch to this view here, which is my living room with the Christmas tree, which is off. And then I'm going to now walk in my apartment to my living room and then start the video. All right, so I'm walking to the living room right now, walking to the living room, walking to the living room. I also believe it's going to be the first time that I'm going to show up full body in the live stream, right? I believe with this microphone. All right, so how are we going to do this? So I'm going to, and for the introduction, I'm just going to say like, hey, this is the Christmas tree. It's got some decoration, but it also has this strand that has been tied up, and it had the Raspberry Pi here and a power supply. I guess that's what I'm going to do, and then I could explain probably that I could load the sequences from the Raspberry Pi directly here, but I'm just going to connect from my computer into the Raspberry Pi and do it remotely. Probably, that's what I want to say. All right. That something goes wrong, I cannot see anything. So let's go for it. Oh, wait. I should get the Christmas thing, you know? Uh, nah, I'm not. Yes, let's do it. All right, hold on. Oh, hold on. All righty. All right. All right. How does this look like? Oh, all right. Let's go for it. Hello! Ho, 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 ho! Merry Christmas! Okay, I'm going to take this off because otherwise the sound. So, welcome. This is Jose Luis, and welcome to another video in. Oh, I'm going to start over again. All right, I'm going to start over again. Hold on. Okay. Hello! Ho 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 ho! Merry Christmas! All right. This is Jose Luis at Parametric Camp, and welcome to another video in this mini series where we've been working towards illuminating computationally a Christmas tree. So, in this video, I would like to actually show you what all those sequences that we have made in the previous videos, what they look like actually run in a real physical tree. So, first of all, welcome to my apartment. This is my living room. And this is the Christmas tree that we have put together for this exercise. So it's a pretty average Christmas tree. It has a bunch of decoration. I would like to thank my partner for that work. I think she did a really beautiful job. And what we've done is we have wrapped a strip of 500 LEDs on top of the tree. So they roughly start somewhere here, and the last ones are the ones on top. And each one of those LEDs can be controlled individually. Each one of the colors of the LEDs can be controlled with a Raspberry Pi that I have right here on this desk. I have a small monitor and a small keyboard in case I want to sit down and play around with the Raspberry Pi here. But what I will do actually is that for this video, I'm going to control everything from my recording studio, and I'm going to just remote into the Raspberry Pi to do all the control and all the loading of the sequences. Okay. The setup of all this system, I would like to thank Matt Parker from Stand Up Maths for his inspiration. He put this together last year, and he also wrote a calibration routine that using computer vision, you could use. He wrote something so that you could turn each one of the LEDs one at a time, take a picture, rotate the tree a few times, and do some interpolation to figure out where the X, Y, Z of each one of the LEDs was in three-dimensional space. I would like to also thank my students at the university, because they were the ones who actually helped me put together the physical tree with the LED lights and to write the code to do the calibration in 3D inspired by some of the code that Matt Parker actually put together also. So big thanks to all of them as well. And without further ado, I think what I'm going to do is I'm going to go to my recording studio, and then I'm going to from there remote and load all those sequences and try them on the tree. See you in a second. Whoop. All right. And now I'm going to walk back to my office, and then we're going to do the typical drill. All righty. So how was that? All right. How was that? All right. Hey, Caleb. So very good to see you, man. Ahmed, good to see you. Thank you. Okay, dokie. So what are we doing then? Okay. So now we're going to start recording from here. Okay, so I'm going to switch to this view. And then I'm going to then switch to the next one where I have my terminal. And in my terminal, I'm going to show how I'm remoting into the Raspberry Pi. And then after that, I will be ready to run some of the sequences. Okay, so I'm going to be switching between my desktop view, this one, and I'm going to be switching between that and that. So I'm going to be switching like this and this. Hey, wait, no? Yes, and this. All right. Awesome. So how are we going to do this? Oh, yeah, sorry. I actually want to. All right, and I just teleported here to my recording studio, but I can still see the tree in my monitor, and everything is happening. Everything that you're seeing is being recorded live from my living room. All right, so what I'm going to do is I'm going to share this thing over here. this is a terminal that I have open right now on my computer, the one that I'm using for live streaming and for recording all of this stuff. Okay. So because running this and recording this from the Raspberry Pi is not very easy, especially with OBS, I would rather do the same thing as I would do in the Raspberry Pi, but I'm going to do it remotely. So what I'm going to do is that I'm going to remote from my computer into the Raspberry Pi by SSHing into it. So I'm going to type SSH, the username, which is Pi, then the IP of the Raspberry Pi in my local network. And then it's asking me for a password, so I'm going to enter the password that I have. And right now you can see that I just logged in remotely into my Raspberry Pi. So anything that I enter in my terminal right now is as if I was doing it on the actual Raspberry Pi. SSHing is a really, it's the most popular way of remoting into servers, remoting into different computers from in a low-level way, if you will, okay, without virtual desktops and all that stuff. So now that I'm here, I can see that my Raspberry Pi has a root, so I can enter the desktop, which is where I've placed most of my files because I'm pretty lazy. And you can see that on the desktop, there's a bunch of files that I've been working and prototyping with. So I'm actually going to enter sequences at parametric camp. I'm going to clear the screen and I'm going to list all the files. And you can see that these are all the sequences that we saved as comma separated values as CSV files with our Grasshopper scripts. I have loaded them with a thumb drive on the Raspberry Pi, although I could also upload them remotely here from my desktop. Okay. If you want to see another version, this is all the files that I have. Now, before we actually load them, I want to show you a few cool things we haven't seen. We haven't talked about this in the stream, but I actually have a bunch of utility files that allow me to play and tweak things on the tree. So, for example, there is a this turn on script that I can run to turn on individual lights by number. So for example, I can type sudo python 3 and then turn on, and then I can type, for example, I want to turn off the first one, 99, 199, 299, 399, and 499. So the six lights at equal sequences. And then what the script will do is that it will turn them one at a time. So if I run this, you see 1, 2, 3, 4, 5, and 6. The one on the top is the very last one. All right. So now those are on, but I can also, I have this flush routine that I can also use to type to basically turn everything off. So I'm going to sudo python blah blah blah, and I'm just going to flush this. All right, and flushing just turns everything off. All right. Okay. Cool. So I'm going to now say, well, now I have a bunch of routines, and the way I'm going to load the routines that come with the CSV files is that I'm going to sudo python 3, I'm going to use the run script, and then I'm going to load one of the ones that I have here as CSV files. All right. Now, which one am I going to use? Well, we're going to go by the chronological order that we did in the videos that we recorded. So I believe the first one is random blinking, correct? But before we do that, let me actually refresh your mind. So we first designed a batch of files that were not aware of the location of the LEDs in three-dimensional space. So the first one was this one, where we basically randomly just turn them on and off in this crazy way. So basically every frame are set, a random amount of them are turned on and a random amount of them is turned off. So if we run that on the tree, so that is going to produce something like that. I don't know if you can see it, but they're all like blinking really heavily, you know, which is kind of cool, but if you ask me, if you see it in the real world, it's not very pleasant, actually. So I'm going to stop this, okay? And then the next one that we did in the simulation was the same idea, but it was with colors, all right? So what this looks like in the Raspberry Pi is sudo python 3 run, and then it was random, blinking, and color, I believe. If we do this, it gets loaded, and it's kind of difficult to see from the webcam, but you can see that now there's color, and it's also like the random blinking, which again, this one is particularly not pleasing to the eye. It's definitely not what you want for a nice, soothing Christmas tree. No, 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 no. All right. So we're gonna cancel that. So what was the next thing we did on the videos? If you remember, we created this animation that was a very simple like pulsing, where all the lights turn on and off at the same time. So how does that look here? So we're gonna say pulse, and I forget what we got. So I think it was pulse uniform. That was the one that we wanted. Okay, so I'm going to load that into the tree. And you can see that they turn all on, and then it turns off, and then they turn on, and they turn off, and turn on. I think the speed that I saved this CSV file was a little too high, so I would probably like these to pulse a little slower. I think so. But anyway, what else did we have? We had another one. This is probably one of my favorites. This is the same idea. All the lights were pulsing, but instead of all pulsing at the same time, they had a random offset between them. So each one of them started and ended at a different pace. So what that looks like on the tree is we have pulse, and then we have pulse with random, was that, I believe? Okay, let us try. Yes, exactly. This one is actually really nice. This one is probably one of my favorites from this set, all right? And this one is still like a little too fast, but if you slow it down to like a 5-second animation or so, it's actually quite soothing and quite nice to see in reality, all right? Beautiful. I'm just going to leave this running while we discuss the next one. The next one that we did was, what was it? It was, the same concept, but instead of white lights, we split all the lights randomly in between red lights and green lights to make it a little bit more Christmas themed. So I think what that looks like is that I'm going to say it was pulse, and then it was pulse random color, I believe. I think that was the one. Exactly. Can you see how the animation is the exact same one, but now half the ones are red and half the ones are green. I have to say, in the webcam, the colors look much better. In the real world, they're very bright red and they're very bright green, and it's a little too much for my taste. I like things that are a little more, quiet, cool. I'm not sure what the adjective there would be. And then the last one that we designed here was one where we basically create a random pulse, but instead of having, and then the lights had a different offset of when they started and when they ended to pulse. But now in this case, instead of having each one of them start and end randomly at any particular, what we did was, if we had 500 LEDs, each one of them started the pulsing cycle at a slightly increased angle than the previous one, creating this cumulative effect, more like imagine like a sine wave flying through all the LEDs across the strip. So what that looks like on the tree is something like this. So random, I think it was called offset. All right. And then you can see, yeah. How cool is this? Come on. The result of this is that it looks like there's a cone of light that is going from the top to the bottom, but that's basically the result of me arranging the LED lights in a kind of spiral around the tree. So that's kind of why this looks like that. Beautiful, beautiful. But what about spatially, or where? Whoa, whoa, what? Wait, hold on. So if you remember, we also work with another set of files where we, for example, we created animations that were spatially aware. And in this case, for coding those animations, we actually took into consideration the X, Y, and Z locations of these LED lights, very much in the way Matt Parker was doing in his original video. So For this, we actually depended on the calibration that we did of the LED lights on top of the tree. We worked really hard on this. My students like really put a lot of effort. Yet I don't think we got a result that was as nice as Matt's. So our calibration had a lot of outliers and that were not for some reason on the tree, and a lot of what I want to say with this is that the results that we're going to see on the tree are actually not going to be as nice as the ones that we see in the simulation, because the sequences have been designed for the coordinates that we have on the simulation. But it turns out that the ones on the actual tree are differ in some areas. They differ quite significantly. That's also the result that all the work we did it somewhere else, and then I had to bring in the tree in a car, so all the lights moved around. So it's a little bit of a disaster, I have to admit, but conceptually it was there. The first sequence that we designed, sequence that was spatially aware of the location of the LEDs, was one where we had, very simply, we had a plane that we moved vertically from the lower part of the tree to the top part, and where all the LED lights that were near that tree started turning on and off in a gradient manner. All right. So what that looks like on the real tree is actually going to give us, let me flush this. So sudo python 3 flush. All right. I'm going to turn it off. And then I'm going to now refresh my mind. We had moving. All right, so I think the first one that we're talking about, so this would be, let's run, and that would be moving, and then it was a Z plane. All right. So this is the same sequence that I just showed in the simulation. And what you can see now is that we can see that there is this notion of a plane that is moving across the tree. I think it's way more noticeable than in the previous one. So you can see that that's actually quite nice, actually. But perhaps the horizontality, or like the perfect section, is not so clean. I think there's something like, it looks like the plane is kind of inclined this way on the physical tree. But again, this is due to the difference between the theoretical calibration that we did of the LED lights, their position in XYZ, and the actual ones on the physical tree. All right. Now, what else do we have? If you remember on the live stream, we did a similar one where we also worked with the location, in the vertical location of the LEDs, but in this case, what we did was that we used the HSV color space. We worked with the hue of the colors, and we moved the hue in Z, creating this effect of a rainbow of color kind of moving along the vertical axis of the tree. So what that looks like on the tree is something like this. So it moves Z, and I think it was, what do we have here? It was rainbow. All right. So that's going to look like, yoo-hoo! Oh, that's too bad. The colors don't look great on the webcam, but they actually look really good on the real thing. Again, maybe full rainbow, it's a little too much for my taste. I'm more of a minimalist, I think. But this one was actually pretty nice on the Christmas tree. Perhaps it's a little too fast also. I like animations that are a little quieter. We also did one in the video that was the same idea, working with a rainbow that was moving around the tree. But in this case, we created one where the rainbow was rotating around the vertical axis. So we can see the effect of that. If we look at this thing in plan, you can see how there's like a rainbow that is rotating. If we see it vertically, it's a bit more difficult to see. So let's see how that looks like on the actual tree. So I think that for moving, we had rotating rainbow. Okay, so let's run that. This one is, yeah, the calibration for this one is a bit more worrisome, but you can see that there is something. You can see there's slight effect of rotation going on. I can see something there, kind of. All right, beautiful. And the last one was this one that was basically inspired by the effect of a spotlight that was rotating around a trajectory that we actually drew So we actually drew a curve that twisted around the Christmas tree. You can see, right? And then we played with the idea of a virtual spotlight, like a sphere of light that was moving around in that trajectory, and then was illuminating the LED lights that were in the area of the one within the radius of that sphere. Okay, so what that looks like, actually I haven't tried this. This is going to be the first time I'm going to try this one live, so I have no idea what this looks like. And this is going to be spotlight. All right, and all right. Whoa, that's cool. Look at that thing. That is so cool. I kind of want to see. Can I go and check it out in the real world? Hold on, hold on. Give me a sec. I really want to see this in the living room. What? Whoa, this is actually quite cool. What? A lot. It's very nice. Alrighty. Okay. So, alrighty. That was really cool, actually. I'm very happy about that. Okay. Well, uh, this was I don't know. Can I call this parametric Christmas trees or something? I don't know what to call this, but I'm just going to say I'm very happy. I'm gonna run this again. It was very cool. I'm just gonna say I'm very happy about the result of this exploration. I would very seriously like to thank again. I would like to thank I would like to thank this guy, Matt Parker, who from Stand Up Maths, who was the first one to come up with this idea, who did a video last year where he explained the whole concept of how to wire this stuff, how to do the computer vision algorithm to track them in 3D, and inspired making this and trying to create these animations with the tools that we like in this channel, C Sharp, Grasshopper, Geometry, and all that stuff. Thanks a lot, Matt, for contributing this to the community. And I also want to thank my students at the university, Indrajit, Amelia, and Jessica, for helping put together the physical tree, the wiring, the calibration, and all of that stuff. If it wasn't for you, I would have probably not been able to do this today. All right, so that was great. Now, with that, I think this concludes the mini series of illumination of Christmas trees parametrically. Thank you very much. This was our 2021 seasonal parametric camp work, whatever that is. Maybe we pick up this again next year. Maybe we don't. I don't know. Maybe we do like a joint thing with Matt. Who knows? All the possibilities are endless. Okay. But in any case, thank you for watching this. It was super fun to put this together. It was super fun to explore it. And it was super fun to share this with everyone as usual. Thank you so much. And if you like this work, maybe consider subscribing to the channel, liking this video, saying hi, or taking everything that you have learned in these videos, coming up with your own animations and submitting them to us on Discord so that maybe we can run them on the tree this year, next year, or whenever we do this. I'm actually planning on holding a Parametric Camp community meeting in a couple weeks after the recording of this video, and whoever has sequences in a CSV format, I would be more than happy to run them on the tree, just like I'm doing right now. All right? Until then, thank you very much, and see you on some other videos. Bye-bye. All right. How was that? Okay, I couldn't see. All right. How was that, huh? All right, beautiful. That was so much fun. Very, very fun. Alrighty. Um, oh, Indrajit. Ah, good to see you. Indrajit is the one who helped me, he was the mastermind behind all this work, actually. Hi, June. Good to see you. Hey, Richard. What's up, Ahmed? All right. So, okay, I think with that, I'm kind of done for today, except for, um, do I want to record a video where I perhaps like do like, hey, we're gonna do animations, we're gonna show stuff working, and we're gonna show animations. We're gonna show animations. Okay, maybe that could work. Maybe I want to do something. Yes, let me shoot a really quick video as an intro for the series. I'm going to do that. Yeah. Yes, I'm going to record. I'm going to record a very, very quick video that I'm going to use as an intro to the series. All right? Okay, so let's do this real quick. Hold on, hold on. I'm trying. I'm trying. Ah, where is my? I want to use the. Hold on. Let me. I want to use the horn, the reindeer horns for this one. I think I left them in the living room. Hold on. Oh, oh, oh! I got stuck in the door. Okay. All right. All right. Hey. I'm gonna have to crouch like this. Okay, so that I can. All right, let's do this. Hello! Ho 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 ho! Merry Christmas! Welcome to another seasonal video series in the channel. This is Jose Luis at Parametric Camp, and welcome to a new video. Welcome to a new mini series where I'm going to teach you. Hold on. Let me. I'm gonna start over again. I'm gonna start over again. I'm gonna start over again. That was not. That was not. What do I want to say actually? I'm going to bring up this one again. Okay. Hello, ho 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 ho. This is Jose Luis. Welcome to Parametric Camp and welcome to a new mini series, a seasonal mini series where we are going to work on this idea of a parametric illumination of a Christmas tree. Wait, what? Okay, I'm going to take this out because otherwise the sound is going to be terrible. What do I mean with this? Well, we were inspired by the work that Matt Parker from Stand Up Maths did last year, where he took a Christmas tree and he wrapped this string of 500 LED lights around the tree, and then he wrote this algorithm to detect computationally where each one of the LEDs was on the tree in three-dimensional space, and therefore obtaining the XYZ coordinates and creating computational illumination sequences and animations that were aware of the volume, the volumetric arrangement of these LED lights. So we took inspiration from him and a little bit of coordination and a little bit of his code as well. And what we did was we put together a version of this idea in Grasshopper with using C# script components. Using C# scripting within Grasshopper. And what I would like to teach you in this mini series is a bunch of different things. First of all, how to go from coordinates that we have all right, so all right, so not okay. I'm gonna start over again. All right. Hello! Ho, 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 ho! This is Jose Luis at Parametric Camp, and welcome to a new seasonal mini-series that is inspired by Christmas and Christmas season. And what we're going to do in this series is that I'm going to teach you through a series of 4 or 5 videos, I forgot how many they were. I'm going to teach you how to generate computationally animation sequences for the LED illumination of a Christmas tree. What? What are you talking about? So this video, this mini series was inspired by the work of Matt Parker from Stand Up Maths, where last year he took a string of 500 LED lights whose RGB colors can be controlled individually, and he wrapped it around a Christmas tree. And then he wrote a few algorithms to detect computationally where each one of those LEDs was in three-dimensional space so that he could have the XYZ locations of those LEDs and therefore generate sequences and generate animations that were aware of the volumetric arrangement of these LEDs. Right? So we took inspiration from his work and a little bit of coordination actually with him and a little bit of the code that he shared openly. And then we wrote an implementation of the same idea and the same logics using C# scripting within the Grasshopper and Rhino 3D modeling environment. So what I'm going to teach you in this series of videos is, first of all, how to take the coordinates of these points in three-dimensional space. So sorry, I forgot to say, in this video, we're not going to cover the algorithms for computer vision and for the calibration of these LED lights in three-dimensional space. That's a bit more complicated than I would like to make it. We're going to assume that this has happened and that we have the coordinates of the LED lights in three-dimensional space. If you don't have them yourself, you're welcome to look at the source code that we're linking in the description and take the coordinates from the CSV file that we will make available for the tree that we put together. And then what I'm going to teach you in these videos is how to, first of all, parse that data so that you can generate the coordinates of those LED lights in three-dimensional space. I'm going to teach you how to create a small animation based on a CSV file that contains the animation. I'm going to teach you how to create a small simulation, so how to render these LED light sequences in three-dimensional space dynamically within Grasshopper. And then by the end of the sequence of the mini series, what I would actually like to teach you is how to generate CSV files that contain every single frame of the animations that we're going to be generating and the RGB colors for each one of the LED lights. We're going to be using this exchange format, these CSV files, as a way of baking these animations to a file that can be read then from the computer that controls the Christmas tree. We're going to make animations such as, for example, this simple soothing, random blinking of the LED lights at a fixed interval. But we're also going to be creating sequences that are aware of the three-dimensionality of this. So for example, we're going to create animations like a rainbow that is kind of moving upside down along the Christmas tree in the vertical axis, or we're going to be creating this nice effect of like a spotlight that is kind of twisting and flying around the Christmas tree, and it's illuminating some of the lights, that are next to that spotlight. The outcome of this will be the CSV files with the animations, but at the same time, by the end of the mini-series, I will also show you how these animations look when actually rendered and displayed on an actual Christmas tree that we put together with the LED lights, with a Raspberry Pi as a controller. And this is my living room right now in real time. Okay. So I hope this mini series is going to be fun for you. I think you're going to learn a lot about the math of creating animations and the idea of how to conceptualize an animation as a sequence of frames, and the geometry behind those relationships. It's going to be quite interesting, I believe. All right, as a part of pretty fun, as you can see already. My living room is ready for this Christmas season, very ready for Christmas season. All right, so without further ado, let's get hands-on, and I will see you on the next video, where I will first, I believe what I'm going to do is I'm going to parse the CSV files and reconstruct all the points in 3D, and then I will teach you how to create a simulation of an animation from those CSV. And then, before I forget, if you think you like this content or you like the work that we're doing, maybe you want to consider subscribing to the channel, or liking this video, or sharing it with your friends, or posting on Instagram, or whatever your sign of gratitude looks like. All right? Thank you very much, and let's get hands-on. I'll see you on the next video. Bye-bye. All right, and with that, I believe that's what I wanted to do today for the live stream. Ooh, that was a lot. Okay. All righty. Well, David, good to see you, man. Well, thank you very much, everyone. That was a lot of fun. And and that was it for this live stream, I think. Now, as I said before, I plan on holding a Parametric Camp community meeting. So that's basically going to be a Zoom call where whoever is interested, we're all going to jump in, and we're going to have like a virtual coffee, a tea, a drink, whatever you feel like. All right. We're just going to chat about the world, about design, about whatever you want to make out of that conversation. I have no agenda for that. The only thing is that since I have the Christmas tree working in my living room, why not, if any of you have time to like experiment with some animations and put them together as CSV files, I will be more than happy to take those, load them into the Christmas tree, and check them out and see how they work. All right. Beautiful. Until that, thank you very much, and see you on the next live stream, whenever that is. I'm not sure. Bye bye.